is, hey? I know, he's so funny. Funny story before we begin. Okay, let's get going.
Made up a joke and it was hilarious. Oh, it's part 2 time.
I don't know. Okay. I think you had to be there. All right, just a review. What's a function? Yeah, what is a function? Greg. Okay, did you hear that? Were you listening or were you talking? What is it? Okay. So, what is it? What's a function?
A function is something where each x only has one y.
Each x has only one y. Okay. So, so far, we have been deriving functions. Okay? Things that you can actually plug into your calculator. Can you derive relation? What are non-functions are called relations? Yes, you can derive them. Are functions relations? Yes, a function is a special type of relation. A relation is not necessarily a function, because a function is a special type of relation. Well, it's more like all cats are felines, but not all felines are cats.
No, it's like what I said.
Yes, how about squares and quadrilaterals, right? All squares are quadrilaterals, but not all quadrilaterals are squares. Okay, it's a special type of relation. Okay. Okay, explicitly solving something. Anyone want to take a guess to be explicitly solve something? Yeah, it's where it is isolated for y, or it's easily isolated for y. So you can solve for y. Okay? You can solve for y. So we're going to look at relations today that are not easily manipulated for y equals. Okay? Like circles. Okay, so far we have differentiated functions in the form y equals f of x. But what if it is not a function? Then we give up. Like, for example, like circles. Yeah. For relations like circles. Hi, come on. You with me? Yeah? Bless you. Right? And circles are always in the form of x squared plus y squared equals your radius squared. Okay? And hyperbolas, do you know what a hyperbola is? Anyone? No. Okay. A hyperbola is a graph that looks like it has two parts to it. So it looked like this. It's like a parabola, but there's two of them. Okay? Or they can also be sideways. That's a hyperbola. Okay? The rules we have covered are not so easily applied. Cody, come on. You're here? Okay, so there's two cases. What if it's not a function, or what if y cannot be isolated? Right, we want just y on one side and only x on the other side. So here's a function where y cannot be isolated. Okay? Actually, it's a relation. It's not a function. So we call this an implicit definition since y is not isolated. So that we've only been dealing with explicit functions. Now we're going to deal with implicit. It's called implicit differentiation. It's a tongue twister. You say it really fast, 5 times. Implicit differentiation. Oh, it's actually not so bad. Okay. So in such cases, we use a special application of the chain rule. Everybody's favorite. No? Did you talk about the derivative of the baby? Did you see the cartoon of the derivative of baby? No? No, it's not a video. It's just a cartoon. The derivative of mummy times the... Yeah, okay, I'll show it to you after. Yeah, the comic? Did you see it? It's like a comic, right? Yeah. Okay, I'll pull it up later. Called implicit differentiation. Okay. Now this example that's given here, I normally don't use this notation, but we can. It must be remembered that y is a function of x. So x is our variable, y is our function of x. Okay, so when we're differentiating y, it's always in with respect to x. It's different than differentiating x. Now, technically, you kind of already have been applying the rules that we're going to learn today. So what we have to do is we have to differentiate both sides. You've already kind of done that. If I give you a function, y equals, I don't know, x cubed, we're already differentiating both sides. Okay, so we're going to take the derivative of both sides. That's what you've been doing all along. Okay, it's a little bit different notation that you're used to. So what's the derivative of y? Y prime. It's dy dx. Or y prime. Same thing. dy dx is you could also write it as y prime. What do you like more? Y prime? I like y prime. I find it's less writing. It's a little neater. Okay? And then what's the derivative of this side? 3x squared. Because it's already with respect to x, we don't need to write this anymore. Right? This is also, we could also write this as dy dx. We've already kind of been using the chain law, because if we differentiate y, it's actually derivative of y is 1 times y prime. And we're going to use that in today's lesson. 1 times y prime is just y prime. So it's like using the chain rule. Here's an example. So we have to differentiate both sides when we have implicit differentiation. It's going to be really easy once we get used to it, just getting our heads around it. So we've already been differentiating both sides. Now we're going to apply it to implicit functions. So how do I differentiate y cubed? 3y squared times derivative of y with respect to x is y prime. So every time we differentiate y, because it's with respect to x, we times it by y prime. It's like the chain rule. Okay? The chain rule is like derivative of the outside times the derivative of the inside. Okay? The derivative of the outside is of y cubed is 3y squared. The derivative of y is y prime. Right? The derivative of y is y prime. I'm gonna skip this example because I like using y prime instead of dy dx. Let's go on. Here you'd have to use the product rule. So this is going to turn into the product rule. Right? Derivative of the first, derivative of x is just 1. Whenever we differentiate x, it's with respect to x. You don't have to multiply it by anything. Plus, times the y, right, times the second, plus derivative of y is y prime times the first. Right? That's all product rule here. And derivative of 7x is just 7. And then what we're going to do is isolate for y prime. We're going to get y prime by itself, and that will give us our derivative. So let's try an example. Okay? Whew, good old implicit differentiation. It's so awesome. Okay, so derivative of y cubed. 3y squared times, because we're differentiating y, derivative of y is y prime. So every time we differentiate y, you have to multiply it by y prime. It's because of the chain rule. So the inside is y, and derivative of y is y prime. Okay?
So it's like a hidden
Because y is a function. Yeah, y is a function, not a variable, and that's why. Okay? Y is a function, not a variable. All right, so this guy, guess what we're going to have to use? The product law. Okay, now you can put the constant on the outside if you like. So minus 3, or doesn't matter. I'm missing a marker. Anyone see? Oh, well, we should change. You could have helped him change it. Okay. Okay. That's funny. Okay, so minus, let's apply, you could either take the constant and leave it on the outside and then just do the product law of x and y. Yeah, it's a little bit easier. Okay, so the derivative of x is 1, and then times, no, we're not differentiating y yet. So 1 times y plus derivative, leave x, leave the first, derivative of the second is y prime. So y plus x, y prime. Okay, so we use the product rule of x times y. So I just kept the constant on the outside. Okay, plus, what's the derivative of y squared? 2y times y prime equals derivative of x squared, 2x. 2x. Okay? Now, what we want to do is get all the y primes on one side, everything without a y prime on the other. I have some simplifying left to do. What do I have to do here? Still, before I start to move things. Distribute that negative 3. So we have 3y squared y prime minus 3y minus 3xy prime plus 2y y prime equals 2x. So what are we going to move to the other side? The negative 3y, because it does not have a y prime. So we want to get everything with a y prime on one side. Because we're solving for y prime, right? We're looking for the derivative. Equals, just wait till we get to double and third derivatives. So much fun. Okay, so we added the 3x, the 3y to the other side. Okay, now what can we do to get y prime by itself? Before we do that, factor out the y prime. So factor out y prime, we're left with 3y squared minus 3x plus 2y. And then divide that. No quotient rule. Only if we were doing second derivative, which we're going to learn about tomorrow. And there you go. There's our answer. So in order to find the derivative at any particular point, is it okay just to know the x value now? No, you have to know the y value. And the reason why is because these are relations, and so different x values has more than one y value. So you would have to know, in order to find the derivative at a particular point, you need to know its x and y value in order to sub this in and actually get a numerical value. So you need to know the actual point, not just the x value. Right? Okay, Was that fun? No? Should you try another one, or do you want to try the next one on your own? Yes? I hear both. Just try it. Just try it. Why not try it? That is what erasers are for. YOLO. You only live once. Okay, derivative of y is 1 times y prime. Okay? Minus, I like to keep the constant on the outside and then derive the inside. So x squared times y cubed. Derivative of the first times the second becomes 2x y cubed plus the first times the derivative of the second. What's the derivative of the second? 3y squared y prime x squared. You might want to put the x squared in there earlier. Yeah, it might be a different order. Y is not a variable, it's a function. Right? Derivative of x with respect to x is just 1. Derivative of y with respect is y prime. Okay? Guys? Okay, equals derivative of x. 1 plus derivative of y squared. 2y y prime. All right, so I had to bring in the negative still. Unless you already did. 3x squared y prime is probably the order you wrote it in.
Why does y prime have to be like
a dash? It's not a 1, it's a dash. It should be diagonal. Yeah.
I'm not good enough to make some stuff diagonal, some stuff straight.
Well, you would never write an exponent of 1, right?
Yeah, it does matter.
Okay, write dy dx then.
It makes me compare.
Okay, well, pick one or the other. I'm sorry. Those are your options.
No, Mr. What's-his-face showed us another way.
dy dx. You write dy dx.
There's another way.
Okay.
There they are.
Yeah, where?
You can't. It's not legible. Or maybe that wasn't it.
Yeah, it's definitely not legible. Okay. All right, getting all the y primes on the same side. Did everyone move them to this side? I'm guessing so. You don't know where you moved them? And then everything without a y prime on the other side, so 1 plus 2xy cubed. Factor out the y prime, what do we get? Kate. Oops. Kate? What do we get when you factor out the y prime? What? Yeah. And so our solution is 1 plus 2xy cubed all over 1 minus 3x squared y squared minus 2y. So close. Okay. Are we okay with this? We're okay? Yeah. Okay. We're getting there? We're below okay. Well, let's keep going then. Okay. So derivative of y is 1y prime.
Oh, sorry. That was very vague question. Why is there a y prime in the first of the two terms instead of three?
Why isn't there one here?
Why is there one? Why is there one there? Yeah.
Did I make a mistake?
No, you didn't.
I moved this to the other side, right? I put all the numbers with y prime on one side. Okay, because we want to isolate. We were solving for y prime. Yeah, so I brought this to this side and this to this side because we want all the y primes on one side, so I can factor out the y prime, divide by this.
Why is it on top? Like if it switches sides, why is it on top?
We're not done yet. You factor it out, and then we divide both sides by this to get y prime by itself. What?
Oh, yeah, okay.
Okay, yeah?
I'm wondering why you put why you put y pi between in the brackets of 3y squared and not like 2x
Okay, guys, I need you guys to stop talking. Ben? Kate? Because I can't hear the questions. And I know this is a tough lesson. I anticipated that coming back today. It's like, awesome. So I'll take that, Tyler. Okay, so where?
So I'm wondering why you put y pi in.
Oh, because it's a product rule. So you derive the first times by the second plus times the first, the derivative of the second. We're doing product rule.
So this one is just the same.
This one, yeah, is just this guy, right? We derive both sides. Okay? Okay, let's try the next question. What's going on? Okay, moving on. Next guy, find the slope of the tangent line to the curve given the following. Okay, so if we want the slope of the tangent line, what do we really need to find? Y prime. Y prime gives us the slope of our tangent line. So we need to find y prime. Okay, can we explicitly derive this? It's going to be really difficult. What would be easier? Implicit differentiation. Okay, so derivative of x squared. 2x. Derivative of minus 5y squared. Product rule, 5 times 2. So minus 10y. And then derivative of the inside, derivative of y, times y prime. What's the derivative of a constant? 0. This one's going to be really easy to isolate for y prime. What's my next step? Sure, add the 10y prime to the other side, because we want everything with y prime on one side by itself. 5 by 10y to both sides. Okay, so we get I'm going to write the y prime on this side. Is that okay? I just like it on the left. Y prime equals 2 divided by 10 can be reduced to x over 5y. Now, that's the equation at the tangent point of the tangent line at any point on our graph. We specifically want at -2 and -1. Who's calling his phone on purpose? Cody? Not as dumb as I look. I'm collecting them today. I'm going to sell them on the street. Good coin. Okay, we want specifically at this point. So what's the slope of the tangent? So here's my x, here's my y. So we can, -2 is our x over 5 times our y.
What is that thing?
At? That's the internet symbol for at. Yeah, sorry. I shouldn't be lazy. At. There you go. Okay, so that we got -2 over -5 or +2/5 is the slope at that particular point. Vincent. I need your phone.
My book is here, but I haven't done anything.
Color display people. Give me your phone. Anyone else who wants to play this game? And keep these for the rest of the day. Yeah. I'm going to keep it till tomorrow. See how you guys function without your cell phones. Okay. He just didn't care. Yeah. He's nicer than me. I'm okay with that. Find the equation of the two tangent lines at x equals 5. Sketch your answer, answer in general form. It's not that bad. Okay, so what's the first thing we could do? Differentiate both sides, okay? Because we're going to solve for y prime. Let's start there, sure. Safe place to start. So here's our function. So if we want to find the derivative, we take the derivative of both sides. You could, but then you'd have two separate. Because of plus and minus. Yeah. You could, but because of the square, you're going to actually have to have two separate equations you have to derive, because you have 1 plus, 1 minus. Right? So with this one, we'll just get one equation. So I find implicit actually a lot easier than explicit in this case. Okay, square root of x squared, or derivative of x squared. 2x plus derivative of y squared. 2y, y prime equals 0, right? Derivative of a constant is 0. All right, now what we want to do? Or subtract the 2x. I'm going to keep y prime on this side. We want all the y primes on one side and everything without a y prime on the other. And then divide by 2y. So we get y prime equals, I'll use purple, a negative x over y. Yeah. Okay, so do we have a problem? What's our problem? We don't have y. We do know x. Could we figure out y? Okay, so let's figure out y. So at x equals 5, let's solve for y. So we have 5 squared plus y squared equals 169. What's 8? Is it just 8? Or is it plus or minus 8? Okay, so you subtracted 25, and what did it give you? You didn't? Oh, we're not done. 144. So y is equal to plus or minus 12. So we have two different points, right? When we square root both sides, because you need to subtract 25 over first. You didn't square your numbers, I don't think. 5 squared. 5 squared.
Yeah, I did. Why can't you square root both sides?
Because of the addition, right? We have to subtract the 5 squared before you can square root. Okay, so we have our 2 points. We have 5 and positive 12, and then 5 and negative 12. So could we find y prime at each of those points? What's y prime at 5 and 12? Negative 5 over 12. So that's one of our points. And what would be our slope at 5 and negative 12? 5 over positive 12. Can we get our equations now that we have a point and we have our slope? Using point slope form. Okay, we can find the equation of both now. Just do separate. Okay, so we have y, let's do this guy first. Y minus 12 equals negative 5 over 12 times x minus 5. Now we just got algebra. Anyway, I got a joke in my head I don't want to say. Because I think I've told you before. See, I only have like 5 jokes. So I tried to spread them out over the 3 years. What kind of underwear does a mermaid wear? Yeah, I told you. An algebra. Yeah. No? Okay. I think we did. I think you're right.
No, we did. Oh, that was on the recording. It was on the recording.
Right. Okay. We can times everything by 12 now, or we can add 12. Add 12? Okay. If you add 12, what do you get? Somebody probably already did that for us. Or add 144 plus 25 is 169? I know, it's crazy. Okay, times everything by 12. Is that right? Anyone work ahead? I guess I could look at my notes. Yeah, that's good. Okay, times everything by 12. 12y equals negative 5x plus 169. Bring what? What's next? The 12y over. What's wrong? What's going to be wrong with it? Can't have a negative x. So I'm going to go straight to going 5x. So this minus 12 becomes a plus 12y minus 169. So that's one equation. We still have one more. I know. It's so tedious. Okay, one more. I'm going to do it down here. So this one's over here. This one's going over here. So it's pretty similar, the equation, because you're going to have y plus 12 instead equals, our slope is 5 over 12, times x minus 5. But it works out to be the same, because if I subtract 144, right, it's very similar. Well, no, very similar. Like the signs are going to be different. But so this is minus 144 over, no, 169 over 12. So times everything by 12. And then subtract the y. So that just the signs are different. That's it. That's a long question, hey? Whew, that's exhausting. Okay, so how was implicit differentiation? Okay?
Get the view, but I don't understand what it is. It's one of those.
Why not? Yeah, you'll be okay. Make a study sheet right now. You'll be fine for tomorrow. No? That's your field. You too? Do you want me to get rid of them? Okay, well, that's personal.